If you are just now viewing this video, you need to go to youtube.com and search for Slope Dude. Watch the video of Slope Dude before you begin this lesson. This is section 3.3. There's a couple of things that we're going to cover here. It is rate of change and slope. Rate of change and slope, and they're very closely related to one another. Your paper, you have where it says rate of change. Do you see that on the top of your handout? I want you to write in what the rate of change is. I know it's small. To find the rate of change, we're going to find the change in y divided by change in x. When we say change in y and change in x, the word change is referring to the difference. The difference in the y values, the difference in the x values. Change in y divided by change in x. So I'm giving you a couple of tables here, and we're asked to find the rate of change. It says, use the table to find the rate of change, explain the meaning of the rate of change. So you have a table of values. We have x values and we have y values. To find the rate of change, they tell us to take the change in y divided by the change in x. It doesn't matter which ordered pairs you use, just pick two. These are all linear functions. So in the first table here, let's find our rate of change.
You pick two always?
Always. To find rate of change, we're going to take change in y, so let's subtract. Let's take 152 minus 76. You should all have a calculator. What is 152 minus 76? What is it?
76.
Okay. Divided by change in x. So if we did 152 minus 76, we need to start with the second order pair first. 4 minus 2. 4 minus 2 is? 2. Let's go ahead and divide. Take 76 divided by 2, and what do we get?
38.
38. 38 what? We need to label. This is not just a number. This is measuring what? Well, what was our y value measuring in our table?
Distance.
Miles. And the x value, excuse me, the denominator was measuring hours. So we would say miles per hour. Miles per hour. We write that as MPH, miles per hour.
What if I don't do this well? Fine.
It says to explain the meaning of the rate of change. So this case is talking about a car that is driving after so many hours the distance it's traveled. So what is 38 miles per hour representing?
How fast it's going?
How fast the car is going. The car is traveling 38 miles per hour. Let's look at the next table. This time we're talking about the number of computer games, which is our x, and the total cost of these computer games. We want to find the rate of change. Pick two ordered pairs. It doesn't matter which two.
They have to be next to each other.
Not necessarily. I could pick the first and the third if I wanted. To find the rate of change, we're going to do change in y divided by change in x. So the change in our y values, I'm going to do 156 minus 78,
78.
which is 78. And 4 minus 2, change in the x's, is 2. What is 78 divided by 2? What did we find? 39 what? Well, what is your y value measuring?
Cost.
Oh, wait, how'd you get
$39.
I did 4 minus 2.
Per game.
the y value is measuring your money, your amount, and the x value is measuring
Cost. No, gain.
x is measuring the number of games. So it's $39 per game. $39 per game. So the meaning of the situation is that each game costs $39. Yes, Randy.
On that one, I did 4 and 6, and I got the same answer.
You should, yes. If you use different ordered pairs, you should get the same. It should represent a linear function here. We should all get the same rate of change.
So, how would you graph that?
We're not graphing. We're just finding rate of change.
Oh, okay.
The table shows how the tiled surface area changes with the number of floor tiles. A, find the rate of change. B, explain the meaning of the rate of change. So again, pick 2 ordered pairs, doesn't matter which 2. Now again, pick the first 2. Let's find the change in our y values. So 96 minus 48 is 48. Divided by 6 minus 3. 48 divided by 3 is 16. What is 16 measuring, or what is it representing in this case? In part A, we found our rate of change, and B, let's describe it. 16 what? Square inches per tile. 16 square inches per tile.
So, on 48 over 3, you divide that?
I did. So each tile is 16 square inches. And we're using 16 square inch floor tiles. Our next one I have written as multiple choice, but we're going to do this together and not multiple choice. It says the table shows how the cost changes with the number of minutes used. Use the table to find the rate of change. Explain the meaning of the rate of change. So let's pick out 2 ordered pairs. This time I'm going to use the second 2 ordered pairs. Let's do change in y divided by change in x. Well, we find change in y. 3 minus 2 is?
1.
Divided by change in y. 60 divided by 40. 1/20 is our rate of change. This is talking about, the y column is talking about our money, correct? And this is talking about minutes. I want you to go ahead and divide. Take 1 divided by 20, and what do you get? 0.05. Why do you think I did that? Haley? Right, we're talking in terms of money. This is going to be dollars per minute. Dollars per minute used. So if this is 0.05, how much money is this per minute? 5 cents. Does it make sense to use 1/20th? 1/20th of a dollar per minute. We don't talk that way, do we? We would say a nickel or 5 cents per minute. So to answer this question here, explain the meaning of the rate of change, what would we say?
5
5
cents per
cents.
every minute.
5 cents per minute. It costs 5 cents per minute to use the cell phone. The next one's going to be a little bit different. I do not have the information organized in a table. Instead, it's written as a graph. It says the graph to the right shows the number of U.S. passports issued in 2002, 2004, and 2006. Find the rates of change for 2002 to 2004 and 2004 to 2006. So we're going to use our change in y divided by change in x to do this. Let's start with 2002 to 2004. What is the y value for the year 2004? Look at your graph. 2004, what is the y value? 8.9. So we have 8.9 minus, what is the y value for 2002? 7.0 or 7.
You always use the second number you pick.
I do, yeah.
Couldn't you just make a chart?
You could have, yes, you could have made a chart, a table. Divided by, or change in our x's, what is the x value?
2004.
Minus
2002.
2002. So 8.9 minus, that's a 7 there. 8.9 minus 7 is 1.9 divided by 2. 1.9 divided by 2? 0.95. What did we just find?
Rate of change.
What is the y value representing?
Passports.
Millions of passports per year. Millions of passports per year. So let's describe this meaning. So it would be 0.95 million, just shy of 1 billion, passports issued per year. You could also think of it as there were 1.9 million passports issued every 2 years. That's another way to think about it. Because 0.95 million doesn't really make sense to talk about in terms of millions. We don't even have 1 million. It would be 0.95, just shy of a million. Let's look at 2004 to 2006. 2006, what is the y value? 12.1. Minus 2004's y value? 8.9. Divided by, what is your x? 2006 minus 2004. So 12.1 minus 8.9
3.2.
is 3.2 divided by
2.
2. So we could go ahead and divide them. If we divide them, what do we get?
1.6.
1.6 what?
Million passports issued each year.
1.6 million passports issued each year.
You had to do both of those? Like 2004 through 2002 to 2004?
Yeah, they're just two separate problems I was asking you. We are going to run out of time. We're not going to be able to get those last 4 graphs done on this note sheet. We'll have to continue those tomorrow at the beginning of the hour. Remember, we did finish the notes from yesterday today, so I've got 3 problems I want to add to tonight's assignment. If you give me just a second, I may need to adjust it a little bit. This may not be the exact assignment. Give me just a second. If the bell happens to ring, please stay put and I can give you a pass the next hour.
those are the right pages.
Wait, so we don't have to do those?
We don't
Just
know.
do 3. That's all.
Yeah, let's see.
What page is it?
Guys, it's the same page. I'm just telling you to omit those problems that I've written up here. We will do them tomorrow. We just didn't get a chance to finish our notes. Now, in addition, I want you to graph a few problems. You're going to have to draw your own X, Y axes, and that should not be an issue. You shouldn't draw that. I want you to graph these 3 problems. So you're doing this assignment. We are omitting these problems because we did not have time to get through all of our notes. I am adding these 3 problems from last night's assignment.
Can't we just do these earlier? Can't we just do this now?
That's 2.
What's
Exact
y
same.
equal on 3?
Y equals
They're
2.
pretty close.
Number 2.
What is y equal on 0? Or 3? Is that 0?
Y
Yeah,
equals 2, x equals -4, and y equals 0.
You got graph paper?
You just draw an x, y axis. It doesn't have to be in little detail.
If we got graph paper at home, do we use that?
Yes, if you do have your own graph paper, you may use it. You don't need anything real fancy to do that.